So if you've connected to a network before, you're likely going to recognize what we're looking at here. These are pictures of a cable that's used very often to connect computers to a network. And this particular type of cable is often called an Ethernet cable. What we want to focus on here is how this cable is able to carry information from one computer to another. So if we cut away the outside jacket here, we can see that the cable is made up of, it's actually 4 pairs of copper wires, so there's 8 wires here total. And in future videos, we'll get into the details of why that is and what all these different wires do. But for now, let's just think about kind of the most basic way that we can imagine to use this to send information. So probably the simplest thing we can do is to just apply a voltage across 2 of these wires. Just so connect some voltage here. And then we can vary the voltage to send information to the other end. So for example, maybe we'll vary the voltage between 0 volts and 5 volts. And so then we can vary this over time. So if this is time going off here to the right, maybe we start at 0 volts for a second, and then we switch this to 5 volts for a second. And then maybe it goes back to 0 volts for 2 seconds, and then up to 5 volts for a second, and then 0 volts for a second, and then 5 volts for 2 seconds. And so if we look at what we did here, we've got basically 2 different states that this can be in. We can either be at 0 volts or we can be at 5 volts. And so we actually call these states, we have a term for this, we call these states symbols. So 5 volts and 0 volts are both the two different symbols that we have. And we call these symbols because we can use them to represent information, like a number. So for example, we could say that 0 volts is a symbol that represents the number 0, and that 5 volts is a symbol that represents the number 1. And so if we look at the voltage here once per second, we've got 0, 1, 0, 0, 1, 0, 1, 1, which we could actually interpret this now as a binary number. If we wanted to, we could even write this number as a decimal. And so 010010111, converting that to decimal, that actually equals the number 75. So I just want to take a moment and go over some terminology here. So as we mentioned, the different states here are called symbols. And the rate that we're sending these symbols is called the symbol rate. So in this case, the symbol rate would be 1 symbol per second. You might also see this sometimes referred to as baud, and baud is a term that literally means the symbol rate in symbols per second. So in this case, with the 1 symbol per second, we refer to this as as sending this information at 1 baud. So if we were sending this 10 times faster at 10 symbols per second, so each of these were a tenth of a second long, then we'd be sending information at 10 baud. So this is interesting. So hopefully you can see how this lets us send whatever number we want to send. But what if we want to send text? Well, since we can send numbers, really all we need to do to send any message we want is to agree on a mapping between a number and then a letter or symbol or some other character. And so one of the most common sort of agreed upon mappings is ASCII. And I got this from Wikipedia as just an example of what ASCII looks like. And it's just this table that maps between numbers and they call it glyph, but it's basically just a character, a letter of some sort. So for example, this 75 that we had up here maps to, in ASCII, 75 decimal maps to the letter K. And you can see they also have it here in binary. And this is what we have up here. The 10011011 is the binary letter for K. And so you can see that by using this mapping and by varying voltages like this, we could send any information that we wanted to.